Welcome to Math TV with Professor V. It is Tuesday, May 30th, 2023. Here's your integral of the day. I had a request to do more multiple integrals, double and triple, so here we go. The directions on this one say reverse the order of integration and then evaluate the integral. So in order to do that, we need to draw out the integration region, which is in the xy plane. Notice here, the first set of limits, cube root of x to 8, are limits for y, okay? How do I know that? Because look at the integration order. We have dy first, so that corresponds to the limits here. So that means y is going to go from cube root of x to 8, and the limits from x are 0 to 512. Ooh, spicy. Okay, so let's draw out the xy plane. I know nowhere in the directions did it say graph, but that's the only way to do it. You can try visualizing some of the more basic ones, but believe me, when we bump it up to 3D, you're going to need to graph for sure. So just get in the habit right now, okay? So x is going to go from 0 to 512, and then y is going from cube root of x, that's the lower bound, up until 8. That's the upper bound. So wouldn't you know, cube root of 512 is 8. Okay, and then you should have an idea what cube root of x looks like. It's going to go through 0, 0. It's going to go through 512, comma 8. Something like this, okay? And so here's the part where you have to be careful. This is the lower bound on y. This is the upper bound on y. So the curve is the lower bound. This is the upper bound. So this is the integration region right here. Okay, now the problem asks us to reverse the order of integration, which means we're going to set up the integral so that instead of being dy dx, it's dx dy. Now the outermost limits of integration must be constants, all right? You have to have the variable functions happening earlier. So in that case, since I'm going to integrate with respect to y last, these need to be constant limits of integration that represent the region as it's bounded in terms of y. So we can see here y is bounded from 0 to 8. Okay, so those are the limits there. Now the next set of limits need to bound the x direction. So you're going to be looking from left to right. Yeah, x direction goes from here to here. Okay. What's bounding it on the left? Just x equals 0. So lower limit's going to be 0. Now on the right, I know that curve is y equals cube root of x. Yeah? But I can't put cube root of x right here because that means after integrating, I'd be left with x's, and I have to integrate with respect to y. So this needs to be in terms of y. So just rearrange y equals cube root of x. That's the same as x equals y cubed. So that's going to be the limit on the right for x. Okay, so again, I'll just repeat here. I'll erase that because we're thinking of it now as y cubed, and then that's 0. So when you're bounding the x direction, this is right minus left. See, right, left. And then here in the y direction, upper, lower, top, bottom, like that. And then the function, you leave it alone. We didn't switch to polar or anything, so we're good. We don't have to change the variables here in the integrand, okay? And then it's very nice because look, had we tried to integrate here, oh my God, antiderivative of 1 over y fourth plus 1 with respect to y, whew, forget it. But now it's so nice because this is all just a constant since we're integrating with respect to x first. This is just a constant. So I'm just going to pick up an x. That's nice. So just rewrite that outer limit, 0 to 8. This is a constant. Just leave it alone. And then antiderivative of a constant is just going to be x to the first. I evaluate that from 0 to y cubed. And then after I do that, I still have dy on the outside. Okay. So this is going to be 0 to 8, 1 over y to the fourth plus 1 times y cubed minus 0. I'm just plugging in y cubed for x. and then we have dy. This looks just terrible, so let's rewrite it so it's more friendly. 0 to 8, y cubed over y to the 4th plus 1 dy. And then now you can see, all right, it's much easier to integrate because now I have this y cubed up here. So I could just do a little u substitution. U equals y to the 4th plus 1. So then du is 4y cubed dy. So 1/4 du is y cubed dy. And then I'm not actually going to write out the u substitution here because I don't feel like changing the limits of integration. So I'm doing it in my head. All right, I'm just imagining that basically I have 1/4 du over u, right? So then I'm just going to have 1/4 natural log, absolute value, u was y to the 4th plus 1, and then I'm still going to evaluate it from 0 to 8. See, so I never wrote anything here in terms of u. I just wrote out a little bit of scratch work so I could visualize, you know, what sort of constants I might need to account for. If you could do it all in your head, whoo, good job. Try it. Okay, and then this is going to be 1/4. We have natural log 8 to the 4th plus 1. Why, that's 4,097 minus natural log 0 plus 1 is 1. And then natural log of 1, we know that's just 0. So then our final answer we're left with is natural log of 4,097 over 4. Beautiful. Okay, hope you enjoyed that integral of the day. I can do more double and triples if that's what you guys want. And also we'll practice switching to polar and whatnot. So this will be good practice for those of you who are warming up to get ready for Calc 3 in the fall. I know that's quite a few of you. Stay tuned. I have more video lectures coming your way. Give the video a thumbs up, subscribe if you're new, and you can also catch me on Instagram and TikTok at MathTV with Professor V. Bye!